So we got a few examples of standing wave problems for today. So let's get to it. I got 4 examples. They hopefully will go pretty quick. So the first is, what is the frequency of the second harmonic of a 0.75 meter long pipe that is closed on both ends? Okay. So first thing, closed on both ends. That's symmetric. So right now, you should be thinking immediately lambda n equals 2L over n. Right? This 2, that's the closed on both ends. That's the symmetric part. Okay? And since we actually know what 2 is and we know what L is, we can say that it's 2.75 over 2. So the wavelength is going to be 0.75 meters. Once you have that wavelength, right, this is a pipe. Anytime you have a pipe, the second thing you notice is a pipe. So you have V equals 343 because it's the air moving inside the pipe that's making the vibrations. So boom, we got velocity, we got wavelength, and as we know that velocity is equal to frequency times wavelength. So 343 equals F times 0.75. The frequency of the second harmonic of this pipe is 457 hertz. Okay. All right, second one here. Similar question. We got a violin. All right. The second harmonic is 900 hertz. And we know the string has a mass per length of 0.0004 kilograms per meter. Apparently that's like a normal mass per length of a violin string, of some violin string. I looked it up. And tension of 80, also kind of a normal tension for a violin. I don't know. That's what the internet said. I'm not a violinist. But this would give us an idea of what the node-to-node distance is. So, one thing to remember here, node to node, right, is equal to 1/2 of a wavelength. So really I'm looking for the wavelength, and I'm just going to divide it by 2. To get there, I need 2 things. I need velocity. All right, velocity, right, this is a wave on a string, is the square root of tension over mass per length. Okay. Right, which is square root of 80 over 0.0004. And if you do that, you should get, this is about 447 meters per second. Okay, I've got a frequency, right? So velocity equals frequency times wavelength. So this is 447 equals 900 times wavelength. Okay. Let me do that. Wavelength is just going to be 0.497 meters. That means node to node is about 0.249 meters. Done. All right. This third, example 3, a 0.1 kilogram string is stretched between 2 poles 2 meters apart. You pluck one end of the string, you see the wave reach the other end in 0.01 seconds, which obviously is not something we could physically do, but roll with it. Maybe you have a really good slow motion camera to do it. And what is the frequency of the third harmonic? Okay, so first off, why did I tell you about this whole pole, the 2 poles, the pluck one end and it reaches the other end in 0.1 seconds? That's because, remember, velocity is still distance over time. Okay, so I've got 2 over 0.01 equals 200 meters per second. Okay, so 200 meters per second, that's our velocity. All right, and I have my length here. My length is 2 meters. So, and this is a string, right? Strings are always, so lambda 3 is going to be 2L over 3. Well, like it's lambda n, and we'll do it specifically in a second. Right? 2L over n, right? Fixed on both ends. Strings have to be. Okay? So this is going to be, right, for our case, lambda 3 is equal to 4 over 3. Okay? So I got velocity, I've got wavelength. Velocity equals frequency times wavelength. 200 equals frequency times 4 over 3. And I've got frequency is 150 hertz. One more example. A pipe that is open on one end and closed on the other has a fifth harmonic of 700 hertz. If the open end is closed, what is the frequency of the fourth harmonic? Okay, so initially, uneven sides. Then we're going to close them both, so it's going to be symmetric. So this is two different sort of pipes, right? Pipe 1, or I guess scenario 1, let's call it pipe 1, pipe A, right, is lambda n equals 4L over n, right? The frequency of the fifth harmonic is 700. And remember, velocity is still 343. This is a pipe, so the velocity of everything. Pipe B, not pipe B, pipe B, right? The difference is this is lambda n equals 2L over n, okay? And velocity is still 343. I need some piece of information about B, right? I don't have information to solve B. I just don't. What I need is the length. This pipe has the same length, right? So we can go 4L over n, right? We know that. This is going to be lambda 5 is equal to 4L over 5. We also know that velocity equals frequency times the wavelength. So 343 equals 700 times 4L over 5. You're going to solve that out. You're going to get L is equal to 0.306 meters. That's wrong. I'm realizing that's wrong right now. I done goofed. It is not that. It is 0.6125. Woo. I done goofed. But now I've got length over here of 0.6125, which means lambda the fourth is going to be 2 times 0.6125 over 4, which is just going to be, this is going to be 0.306. I didn't goof. I had it written down. I just looked in the wrong place. That's what I thought it was. Okay, never mind. No goof. No goofing. I didn't goof. I goofed in thinking I goofed. Okay, velocity 343 equals 0.306 times the frequency. Frequency is 1,121 hertz. Okay. And that's it.